Hey guys, this is Bill. Welcome to my channel. In this video, I'm going to teach you two methods to run a linear regression. One of the methods is to use the function LM. The other is to use the formula that I have previously derived in my previous videos. Alright? So to understand what I'm going to say in this video, you do need to have some basic knowledge about R or R Studios. If you don't have such knowledge, there are a lot of online resources which are self-explanatory and you can learn R from there. And I've also uploaded this script and the PDF file in the description link below, so you can download them if you wish to. Alright, so without further ado, let's get into the codes. So for the first line, I actually set seed for this entire script such that you can get the same numerical results if you want to run the scripts. Next few lines, I generate a few different sequence of random numbers. So for x1, it's generated from a standard uniform distribution with 500 observations. x2 is sampled from this vector 500 times with replacement, of course. And then x3 follow beta distribution, x4 follow gamma distribution, x5 follow a standard normal distributions. And note that all of them have 500 observations, all right? So those will be our independent variables, and x5 itself would be the error term, all right? So after that, I also generate a vector of y. So y is basically a linear combination of all the 5 variables. However, here x5 is denoted as the error term, so it will not be included in the linear regression that we are going to do later on. And also, if you want to take a look at your independent variables of x1 up to x5, you can use the view function here. I have commented out this line because when I run a whole chunk, I don't really want to view the independent variables, all right? So I can run the current chunk, so it will run all the codes here for me, all right? So when you run the current chunk, you don't really have any output because I have not write any lines that will generate output for me. So if you want to take a look at y, you can just key in y in the console and then you can take a look at the variable y, all right? So this vector will just be our dependent variable here, and we are going to run y against the rest of the independent variables, all right? So now let's go into the first method that I'm going to teach you on how to do a linear regression, all right? So the first function that we can use is LM. So you basically just need to write LM here, and then in the bracket, you need to key in the formula. So for the formula, on the left-hand side, you have your dependent variable, which is y, and followed by a curly sign. After that, you have all your independent variables here. And each of the independent variables is separated with a plus sign, all right? After you get the results here, you need to store it or assign it to a variable. So here, I assigned the linear regression results into a variable named model. So in order to look at the results, you need to use the summary function. So I have previously run the code already. That's why I have the results here, but let me just run it again, all right? So run the current chunk, it will run the 2 lines here, and here are the results. All right, it will output you the residuals. So the residuals is basically the difference between the predicted value by the model and the actual values. So the minimum value, the first quantile, median, third quantile, and maximum values of the residuals are all reported here. Well, at this stage, we're not really interested in it. Rather, we are more interested in the estimated coefficients for each of the independent variables, all right? So here are the results. So this column is basically the estimates for the coefficients, all right? As you can see, they are pretty close to the actual model here, all right? So let's just take a look at for x1, the estimate is 9.94 and the actual value is 10. So they are pretty close to each other. That basically tells you that indeed, a linear model can approximate the actual model pretty well here. And here we also have a p-value. So the p-value, when it's very small, it tells you that the coefficients here are statistically and significantly different from 0, all right? And this p-value is rather large. It basically tells you that the intercept value is not very different from 0. And as you can see, indeed, we didn't include a bias term or an intercept here in the actual model. So yeah, we can say that this model fits, this linear model actually fits the actual model pretty well. And also you have a F statistic here, and you have an additional p-value. The p-value is very small. It tells you that the whole model is statistically significant. All right, so after the first method, I'm going to give you the second method, which is to use the formula that I have taught you in the previous video. So what I did here is to sub in the formula. All right, so solve basically gives you the inverse of a matrix. All right, and then T denotes the transpose, and the matrix multiplication is to use the percentage multiplication percentage sign. So we can get the coefficients pretty easy here. However, if you take a careful look at the code, you realize that I do have an extra line here. So the extra line here generates the X matrix. The X matrix includes not only the independent variables, which runs from x1 to x4. We also have an additional vector, which has 500 entries, each of the entry being 1. So why is that so? This is because we do need to estimate the bias term, right? Or the intercept term. You can say that 1 would be the X value for the intercept. That's why we have an additional column of 1. All right. So after running these two lines, basically you get the coefficients already, and the cat here basically means print. These three lines will print out the coefficients computed using method 2. All right. So let's run the whole chunk of codes, and indeed we have the coefficients here are exactly the same as what we have obtained by using LM function. All right.